Please explain entropy. Entropy. I've had so many discussions and arguments about entropy in the past. Anyway, what is entropy? Entropy is a fundamental concept in physics, but also in chemistry. Okay. And it essentially is related to the degree of disorder or the degree of randomness in a physical system. What's a physical system? Let's say you have gas in a box. That's a physical system. How much disorder, how much randomness do you have in this gas in the box? That's that measure of disorder or randomness is called entropy. So entropy, it plays a crucial critical role in the second law of thermodynamics, and it has important implications in various processes, chemical reactions, and so on and so forth. So in physics, we have a branch of physics called thermodynamics, in which entropy is a measure of the number of, see, you have a system, you have a gas in a box. What is the number of specific ways in which your gas, this thermodynamic system, can be arranged without changing the overall state of the system? So this is the measure of the randomness of the system, the measure of disorder of the system. So the ways in which you can arrange a cold gas, it's different from the number of ways in which you can arrange a hotter gas, and so on and so forth, ice versus water, and so on. So the second law of thermodynamics, it says that the total entropy of an isolated system can never decrease over time. And this implies that natural processes move from states of move they tend to move, they want to move towards a state of maximum entropy or thermodynamic equilibrium. And then you bring in statistical mechanics and all that. You have the Boltzmann entropy formula: S is equal to KB ln omega, where KB is the Boltzmann constant and omega is the number of microstates. S is entropy, and so on and so on and so forth. So entropy is a statistical property of a system. It's the measure of the disorder of a system. An intrinsic particle like a proton or a neutron or a bound state can never have entropy. It's only a combination, it's only a bunch of particles, a system made of lots of particles, that can have entropy. And there is entropy has it has a meaning in chemistry as well. Entropy, when you have a chemical reaction in chemistry, the entropy of the system changes, and the change in entropy it tells you, it is it tells you how spontaneously the reaction happens. So the spontaneity of a reaction, it is dependent on the kind of entropy change the system undergoes in a chemical reaction. And there is something called the Gibbs free energy equation, and that tells you how it happens. The positive or negative change in entropy will determine the spontaneity of the reaction, and so on and so forth. So entropy, it is, you can factor in molecular motion, you can factor in lots of other things, but overall it's the measure of the disorder of a system. In a system, you have lots of components, typically gas molecules, or you have water, or you have a liquid. So you have molecules in various configurations, and the amount of disorder in a system, that is the measure of that, is the entropy. So for example, if you take the system, the human brain is a highly ordered system, so its entropy is going to be incredibly low. And probably the lowest entropy system in the universe may be the human brain, because it's so orderly, so there's very little disorder, and so on. So all of that is entropy. Entropy is it's a thermodynamic property, it's a statistical property of a system. And please remember that intrinsic particles do not carry entropy, they don't have entropy.